As in our last class, I was talking about homologous series. Homologous, good evening. Homologous series, what does it mean? As we are having our family, as we are having our khandan, in that khandan, many things are common and like that, homologous series is also there. For example, alkanes are having CnH2n plus 2 general formula means all member of this alkane homologous series will be having this general formula and their physical properties will be having their chemical properties will also be common and their method of preparation will also be almost same. See, between two consecutive members of the same homologous series, it can be alkane, it can be alkene, or it can be alkyne, or arene, or alcohol, or something else too. In the same homologous series, between two consecutive members, there will be difference of CH2. Difference between two consecutive members in the same homologous series will always be one carbon atom and two hydrogen atoms. And what second is the difference in atomic weight between two consecutive member will always be 14 AMU. This is 12 and this is 2. So 12 plus 2, 14. So one carbon atom and two hydrogen atoms. This will be the difference between two consecutive members of the same homologous series, whatever that homologous series is. And by weight, the difference between two consecutive member will be 14 AMU. 14 AMU. So this is what the characteristic feature of homologous series. For example, they can ask you C3H7OH and C4H7OH. They may ask you, they may ask you, they may ask you whether they are the members of the same homologous series or not. They can ask you questions like this. So see here how you will be doing it here. CnH2n, CnH2n. So C is 3, so N is 3. So 2 3s are 6, but here it is 7, so plus 1. CnH2n plus 1 OH. Now see this one, CnH2n. Here, what have you written? Cn, N is 4, and here H is 7. So that is 2 into 4 will be 8 minus 1. Then only it will be 7 OH. So see here, this is alkyl alcohol. What this is? This is alkyl alcohol. This is alkyl alcohol, and this one is alkenyl alcohol. So are not the members of the same homologous series. How we can say they are not the same members of homologous series? Because their general formula is not same. Since their general formula is not same, so are not the members of the same homologous series. One alcohol is having general formula. One alcohol is having general formula CnH2n plus 1 OH, and second alcohol is having CnH2n minus 1 OH. So are not the members of the same homologous series. So this is all about the homologous series. Questions they may be asking you like this only. So you have to check their general formula. If general formula is same, then only they can be member of the same homologous series. If general formula is not same, then they will not be the members of the same homologous series. So this was your last point. Now see what next is. Next is nomenclature of organic compounds. See, for nomenclature, there is a union. For nomenclature, there is a union. That union is called I. That union is called I. That union is called IUPAC, International Union of Pure and Applied Chemistry. Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. What's the meaning of pure chemistry? Pure chemistry means bookish chemistry. What's the meaning of pure chemistry? Pure chemistry means bookish chemistry. So what the meaning of pure chemistry? Pure chemistry means bookish chemistry. And what the meaning of bookish chemistry? And what the meaning of applied chemistry? Bookish chemistry. And what the meaning of applied chemistry? What the meaning of applied chemistry? Means that part of chemistry which can be proven practically right. The part which can be proved practically, that is called applied chemistry. So this is bookish chemistry and the practically proven chemistry. Practically proven chemistry, that is called applied chemistry. Applied chemistry. So this is what the meaning of pure and applied chemistry is. Now see, as in our last class we discussed some compounds. See what this is. This is common name is dimethyl. This is methyl. This is methyl. Dimethyl. Common name is dimethyl. And what this CO is? CO is ketone. So dimethyl ketone, or its common name is acetone. Its another common name is acetone. Acetone we need to remember. There is no system to understand that. Now what will be the IUPAC name of this compound? See here, how many carbons are there? 1, 2, and 3. So 3 carbons are there. So prop, and between carbon there is a single bond. So ane, and C double bond is one. In IUPAC it is known as one. So propanone. On which carbon atom this one is there? On second. No other carbon atom can be possible on which this C double bond O can be there. So that is 2-propanone or propane 2-on. 2-propanone or propane 2-on, both are one and the propane 2-on one. Both are one and the same thing, but it can't be propanone 2. It can't be propanone 2. That is wrong. That is wrong. But see, if this is not there, this option is not there in your question paper, this option is also not there in question paper, only this is there, then you will be writing this answer. Of course, it is not the correct one, but what other options they have given in compared to them, this is the most accurate one. So you'll prefer this answer over them. So, but 2-propanone and propane 2-on are the right answers. This propanone 2 can't be the right one. But since no other option is as much correct as propanone 2 is, so we'll be writing this answer. Of course, it is not the right one. Then also we'll be writing this answer only. Now see, this all is over. Now we'll discuss some more. Structures. See, CH3, CH2, CH2, C double OH. Now see, you will start counting carbon atoms from where? You will start counting carbon atom from that side. So the number given to the carbon atom of the functional group should get the lowest one. If you will start from here, then this will be 1, 2, 3, 4. This COH will be the 4th carbon. And if you will start from counting carbon from here, then that COH carbon will be getting the 1 number. So functional group should get the lowest number. So we'll start counting carbon from here. 1, 2, 3, 4. Total, how many carbon atoms are there? 4 carbon atoms are there. So it is but. And on first, and in between all carbon atoms, single bond is there. So butane. And on first carbon atom, functional group COOH is there. So will be butane 1 oic acid. Butane 1 butane 1 oic acid, or you can say 1 butanoic acid. Whether you will be writing 1 or not, it's not a big issue, because then also it will be the same. 1 butanoic acid or simply butanoic acid or butane 1 oic acid, all are one and the same. So this is about butanoic acid. Now see, there is one more compound they have given here, that C6H6. What this C6H6 is? Benzene. That is what they have given here. Now see what they have written: C6H5O, 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 CH3. What this is? C, either phenoxymethane, this will be phenoxymethane. In this case, this O is attached with phenyl group, not with methyl group. Or you can write this as methoxybenzene. 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 Either this O will be attached with this CH3 or with this C6H5O. So if it is attached with this C6H5O, then it will be phenoxymethane. And if this O is attached with this methyl, then it will be methoxybenzene. See, when you are going out, when you are young enough and going out, then you will always be holding finger of your parents. So which one is the smaller one? The CH3 is the smaller one. So CH3 will always be attached with this O. So what would be the right one? It would be methoxybenzene. This will be the right one, and this will be the wrong one. So phenoxybenzene is not the right answer. What right answer is? Methoxybenzene. And its common name is methyl. Its common name is methyl phenyl ether, or you can say anisole. Anisole or phenyl anisole. Anisole. Anisole or phenyl methyl ether. This will be the right answer. This will be the right answer. So we can discuss here some more examples too, so that we can understand this concept, what this concept is. Now see what your next example is. Now we'll be taking C6H5O C2H5. So which one is a smaller, C6H5 or C2H5? C2H5O is a smaller. So it will be ethoxy, benzene, and not phenoxyethane. Not phenoxyethane. That will not be the right one. Phenoxyethane. This won't be the right one. So it will be ethoxybenzene, or its common name will be phenitol. Its common name will be phenitol or ethyl phenyl ether. Fine. So like this, this they have given anisole only, this one, but I took this also, phenitol also. Now see some more examples we'll be discussing here. C6H5NH2. What C6H5NH2 is? Aniline. What's the meaning of aniline? Aniline means indigo-like. Since this compound is like as indigo, so that is why this compound C6H5NH2 is known as aniline. Now see, if we'll be writing C6H5COCH3, what it is? This CH3CO is aceto. This CH3CO is aceto. This is phenyl plus on, phenon. Phenyl plus on is phenon. So it is acetophenon. It is a phenon. Or what we can say, it is methyl phenyl ketone. Its common name will be methyl phenyl methyl phenyl ketone. Methyl phenyl ketone. This will be the common name of this acetophenone. Now see, they have given one more ether, so I'll discuss that too. CH3OC2H5. What this is ethyl. What this is methyl, and what this is ether. So ethyl, methyl, ether, or this will be common name. This will be common name. What will be its IUPAC name? See, out of the CH3 and C2H5, which is the smaller one? CH3 is the smaller one. So this O will be attached with this CH3. So that will be methoxy. That will be methoxy. That will be methoxy ethane. That will be methoxy ethane. So that's all. That's all for this nomenclature of organic compounds. Now we'll go to the. This all is over. Now we'll go to the next one, that IUPAC system of nomenclature. See, what are the conditions? Carbon chain should be, what are the rules for IUPAC? What are the rules for IUPAC? Rules for IUPAC, first rule, carbon chain should be longest possible. Carbon chain should be longest possible. Carbon chain should be longest possible. First rule, carbon chain should be longest possible, and functional group should be given lowest number. Should be given, and functional group should be given lowest number. So these are the two rules. If you have to choose any one, if you'll be taking longest possible carbon chain, then functional group will be getting a bigger number. Fine. And if you'll be taking a smallest number, if you'll be giving a smallest number to functional group, then carbon chain will not be the longest possible. So you'll prefer the lowest number of functional group over, you will prefer second point over first. Whether you will get longest possible carbon chain or not, but you should give functional group lowest possible number. Functional group should be given lowest possible number. That's far more important than the longest possible carbon chain. So that's the point. We should remember this. Now see, you can understand this like this. See here, this is 1, this is 2, 3, 4, 5. Total, how many carbon atoms are there? 5 carbon atoms are there. So pent. And between carbons, single bond is there. So ane. And on second, one is there. Pentane to one. So 2-pentanone, this will be the IUPAC name for this compound. So this is these are the longest possible carbon chain and functional group. You can't start counting carbons from here. 1, 2, 3, 4. Then this will be pentane 4 on. So out of pentane 4 on and pentane 2 on, in which case we are giving lowest number to functional group pentane 2 on. So that will be the right name. So like this, you can write names of the different organic compounds. Now see, this alkane is already over. This alkane is already over. Now see, this second carbon is having 1, 1, 2. From here also it is 1, 2. But third, fourth is not having any group, and here 1, 2, 3, 4. This fourth is having third, and fourth is having another group. So you'll start counting from this side, not from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on second, methyl is there, and on eighth also methyl is there, and on fourth, ethyl is there. So 4-ethyl, 2,8-dimethyl, 2,8-dimethyl, 4-ethyl, 2,8-dimethyl, nonane. Total 9 carbon atoms are there. So non, and between carbon-carbon single bond is there. So 4-ethyl. 4-ethyl, 4-ethyl, and 2,8-dimethyl nonane. This will be the IUPAC name of this compound. Now see, this is what will be the name of the compound. Now see what next is. See, this is very important here. I'll be teaching you radicals. So how radicals are formed, that's very important. See here, alkane. If we'll take out one hydrogen atom from alkane, then what you will get? You will get alkyl radical. What you will get? Alkyl radical. See what the general formula of alkane is: CnH2n plus 2, or you can write it like RH2. After taking one H from there, what you will get? You will get R, or you will get CnH2n plus 1 hyphen. This 1 hyphen means one valence or site is available for attachment. So you'll be, that's why you will be writing 1. So this is alkane, this is alkyl. So alkyl is CnH2n plus 1 or R. Example, if you'll be taking CH4, then this CH4 will be losing 1H, and what you will get? CH3. What CH3 is? Methyl radical. If you'll be taking C2S6, from that C2S6, 1H will be lost, and what you will get? You will get C2H5. What this C2H5 is? This will be ethyl radical. This C2H5 will be ethyl radical. Now see, if we'll take C3H8. Now see, if we'll take C3H8, C3H8, that's C3H8, that C3H8 will be propane, and this propane will lose 1H, and what you will get? You will get C3H7. What that will be? That will be propyl radical. That will be propyl radical. Now see, C4H10, that will be C4, that will be forming C4H9 radical. That is butyl radical. That's butyl radical. Now see, C5H12, that is pentane. What it is? It is pentane. What it is? It is pentane. This pentane will be losing 1H, and what you will get? C5H11, that is pentyl radical. That's pentyl radical. Now see here, butyl and pentyl, we'll talk about this all. This is C. If you are writing CH3, CH2, what this is? This is normal propyl. What this is? This is normal propyl. This is normal propyl. See, I want to explain you here the difference between normal, iso, neo, and primary, secondary, and tertiary. See, where is the valency available for attachment? This is the site where valency is available for attachment. This carbon is attached with how many carbon atoms? 1 carbon atom. So it is normal, and it is known as 1 degree also, because it is attached only with 1 carbon atom. That's why it is called 1 degree or primary. 1 degree or primary. Now see the next one. You can write it like this too. You can write it like this too. CH3, CH, CH3, and here CH3, CH3, and here availability of valency for attachment, site for attachment is there. So this is isopropyl. What this is? This is isopropyl. See, where valency is available or site for attachment is available, vacant, this is the point. And on this carbon, how many carbon atom is attached for that? 2. So this will be 2 degree. This will be 2 degree. That is secondary. So normal propyl is primary radical and isopropyl is secondary radical or 2 degree radical. Fine. So 3 degree can't be possible there in propyl. Now we'll see butyl radical. So propyl can only be normal propyl and isopropyl, only 1 degree and 2 degree. 3 degree in propyl is not possible. So now we'll go to the butyl. Now see, as I already told you, C4H9 is butyl. Radical. We can write it like this. 1. CH3, CH2, CH2, CH2. This is normal butyl radical. That is 1 degree or primary. That is 1 degree or primary. Second can be written like this too. Second can be written like this too. CH3, CH2, then C. CH3, CH2, CH, CH3. Here, availability of site for attachment is there. So this is also butyl, but this was normal butyl. This is isobutyl. How we can say it is isobutyl? Because here the carbon which is having vacant site is further attached with 2 more carbon atoms. Carbon which is having vacant site is further attached with 2 more carbon atoms. This is one and this is another. So it is isobutyl, or you can say 2 degree or 2 degree or secondary. Isobutyl or 2 degree or secondary. Now see, we can write it like this too. You can write it like this too. See here, that carbon which is having empty site, vacant site, is further attached with 1, 2, and 3 carbon atom. So it is I am writing here butyl. This is 1, 2, 3, 4. Fine. This is neo butyl or 3 degree or tertiary butyl radical. So in this way, you can show, in this way, butyls can have primary, secondary, and tertiary, all the 3. Normal, iso, and neo, all the 3 types of radicals. Now see the pentyl. C5H11, that is pentyl. This pentyl radical can be like this. This is normal pentyl. This is normal or 1 degree or primary pentyl. Now see the second one. You can write it like this too. This is first one. Now you can write it like this too. Fine. Now we can write like this too. This is 3 degree or neopentyl. Or 3 degree or 3 degree or tertiary radical. Now see, you can write it like this too. Here, attachment vacancy is there. This site is available for attachment. Fine. So this will be isopentyl or 2 degree or 2 degree, sorry, or 2 degree or secondary. So like this, you can write this all here. Fine. So if C, now I'll explain you here primary, secondary, and tertiary carbon atoms. I'll explain you here primary, secondary, and tertiary carbon atom. Now see, here, this carbon atom is further attached with one carbon atom, and this carbon is also attached with one carbon atom. So these two carbon atoms are primary or 1 degree carbon atoms. And what about this carbon atom? This carbon is further attached with 2 carbon. This carbon is also further attached with 2 carbons. So these two carbons are known as secondary, these two carbons are known as secondary or 2 degree carbon atom. Secondary or 2 degree carbon atoms. Now see, if we have written like this, then this will be primary. This will also be primary. This and these two will be 2 degree secondary. And what about this carbon? This carbon is further attached with 3 carbon atoms, so will be known as 3 degree. So 1 degree, 2 degree, and 3 degree carbon atoms. Now see one more example. This carbon is further attached with 1, 2, 3, 4 carbon atoms. So this carbon atom will be known as 4 degree. This carbon atom will be known as 4 degree or quaternary carbon atom. This carbon atom will be known as quaternary or 4 degree carbon atom. So in this way, you can judge whether a carbon atom is primary, secondary, tertiary, or quaternary on the basis of number of the carbon atoms attached to the carbon atom which you are talking about. On that basis, we can say it is primary, secondary, tertiary, or quaternary carbon atom. So this is what they have written here: isobutyl, secondary butyl, isopropyl. See, isobutyl, this is 1 degree. This isobutyl is 1 degree. This isobutyl is 1 degree because this carbon is further attached with only one carbon atom. And this secondary butyl, why? Because this radical where the valency site is available for attachment is attached with 2 more carbon atoms. So it is secondary butyl. And here, this is neopentyl and is 1 degree. 1 degree. Why it is 1 degree? Because this is attached with only one carbon atom. And what about the tertiary butyl? Here, this carbon is further attached with 3 more carbon atoms, so will be known as tertiary butyl. So in this way, you can judge. Primary, secondary, tertiary, and quaternary radicals. Now see, this all is over. So we need not to bother about all these things. As I told you, carbon chain should be longest possible. Now see, in this this I'll be explaining here. Total 9 carbon atoms are there. Here in this compound, total how many carbon atoms are there? 9 carbon atoms are there. And on fifth carbon atom, this side chain is there. This side chain is comprised of 3 carbon atoms, 1, 2, 3. So on fifth, on fifth, on fifth, on fifth, on fifth, propyl is there. On fifth, propyl is there. On fifth carbon, propyl is there, and total it is 9 in number and single bonded, so no name. Now see on this fifth carbon atom, this propyl is having 2 radicals. One is this and one is this. This is first carbon, second. So 2,2 dimethyl. 2,2 dimethyl propyl. So like this, we'll be writing 2,2 dimethyl propyl nonane. Side chain is further having side chain. So whenever it is like this, we'll be writing. What next? See what next is. So you should go through this all. See here, it should be written as 2,5,6 trimethyl octane, not 3,4,7, because 3,4,7 plus 7, 14. This will be 14, and here 2,5,7 plus 6, 13. So 13 will be smaller than 14, so you'll be preferring 13 over 14. So 2,5,6 trimethyl octane, not 3,4,7 trimethyl octane. So this is about the nomenclature of certain organic compounds. Now what next is nomenclature of organic compounds having functional groups. Nomenclature of organic compounds having functional groups. Now see, already some compounds we have discussed, but we'll be discussing here some more compounds so that we can come to know how to write the names of the organic compounds. Before going this to further, we should know different functional groups, their name and their priority order, which is a stronger functional group. This all we should know. Now see, the strongest functional group considered here is COOH. In NCERT, it is given COOH, that's the strongest functional group, but in actual, sulfonic acid is the strongest functional group. Other than NCERT, in every book, SO3H will be the strongest functional group, but in NCERT, they have given SO3H as the strongest functional group. So obviously, you have to write answer from NCERT there in NEET or JEE, etc. So you'll be following this order on. So, but you should not get confused. That's why I'm giving you that SO3H is the strongest functional group. This is what it is written there in other books. Now see, this is the strongest functional group, that is carboxylic acid. Its IUPAC name will be oic acid. This also there in the is given there in the table. And this is sulfonic acid. Then weaker than that is ester. This is acyl chloride. This is amide. This is cyanide, that is nitrile. This is aldehyde. This is ketone. This is alcohol. This is amine. This is alkene. And this is alkyne. So this is the order of priority of various functional groups. The strongest functional group according to NCERT is COOH, and then sulfonic acid, then ester, then acid halide, acid chloride, then amide, then cyanide, then aldehyde, ketone, alcohol, amine, alkene, and alkyne. So this is the order of priority of various functional groups, or order of decreasing the strength of functional groups. Now see what they have given here. See, they have given here this compound. If you'll start counting from here, 1, 2, 3, 4, 5, 6, this alcohol will be there on the 6th carbon. But if you'll start from here, that alcohol will be there on the 3rd carbon. So as I told you, functional group should be given lowest number. So you'll start counting from this side. On 6th carbon, methyl is there. On 6th, methyl is there. So 6 methyl, 6 methyl. Now see, how many total carbon atoms is this compound is there? 8. So oct. And all carbon atoms are single bonded. So in, and on 3, all is there. So octane, 3, all. 6 methyl, octane, 3, all. This will be the IUPAC name of the compound. Now see here, if we start counting from this side, 1, 2, 3, 1, 2. So 2 is the smaller, so we'll start counting from here. On second, own is there, and on fourth also own is there. Total 6 carbon atoms are there, so heads. Total 6 carbon atoms are there, so heads. And between carbon atoms, bond is single, so ane, hexane. And on second and on fourth, 2, 4. 2, 4 di on 2, 4 di on. So hexane 2, 4 di on will be the name of this compound. Hexane 2, 4 di on. This will be the name of the compound. Hexane 2, 4 di on. So hexane 2, 4 di on. What next is? See what next is here. 1, 2, 3, 4, 5. On fifth, keto is there. If it is suffix, if it is suffix, if it is suffix, then keto. If it is suffix, then keto. Sorry, if it is suffix, then on. And if it is prefix, then keto. And when this will be used as prefix, when more stronger than this functional group is there, that is carboxylic acid. Carboxylic acid is more stronger than ketone now. So this will be given priority. Then this won't be used as a suffix. This will be used as prefix. And prefix for the C double bond O is keto. So 5 keto or oxo. 5 keto or oxo. And total how many carbon atoms are there? 6 are there, and all are single bonded. So ane, hexane, hexane. And on first, oic acid is there, hexanoic acid. So 5 keto or oxo, 5 keto or oxo, 5 keto or oxo hexanoic acid will be the name of this, compound. Will be the name of this compound. 5 keto or oxo hexanoic acid will be the name of this compound. Now see the next one. This all table we should know. Alkanes can only be the alkanes can only have suffix. Alkanes also can have only suffix, no prefix. No prefix. If carbon-carbon single bond is there, then suffix ane will be used. If carbon-carbon double bond is there, then suffix ene will be used. If carbon-carbon triple bond is there, then suffix ine will be used. There will not be any prefix for alkane, alkene, or alkynes. Now see, arenes will also not be having any prefix, can also be used as a, can only be used as arene or benzene. There is no prefix or suffix for them. Halides can never be used as a suffix, can only be prefix, that is halo. And alcohols can only be used as suffix. Then when it is used as suffix, then its name will be all. And if it is there is more stronger functional group than this alcohol, then this all can't be used. Then it won't be suffix, it will be prefix, and the prefix for alcohol will be hydroxy. Now see aldehydes. Aldehydes are having CHO functional group, and their prefix will be formyl or oxo, and suffix will be al. And for ketones, prefix will be used as oxo. There is C double bond O, and suffix will be on. Now see nitriles. Nitriles is CN. Nitriles, prefix for nitriles will always be, cyanide. Sorry, will always be cyano, and suffix will always be nitrile. For ethers, prefix can only be alkoxy. There will not be any suffix. And for carboxylic acid, prefix, that is COOH, prefix will be carboxy, and suffix will always be oic acid. For carboxylate ions, there will not be any prefix, but suffix used will be oid, that is aster. Fine. For COOR, that is asters, suffix oid will be used, and prefix will be alkoxy-carbonyl. This is alkane, so alkoxy-carbonyl. And for acyl halides, prefix will be halocarbonyl and suffix will be oil halide. So this is all about all these prefixes, suffix, etc. present there in any compound. Then what next is, if NH2 group, that is amine, is there, then prefix used will be amino and suffix will be amine. Methanamine, ethanamine, propanamine, phenylamine, single word. And if COH2, that is amide, so prefix will be carbamoyl and suffix will be amide. And for nitro compounds, that is NO2, prefix will be nitro and there will not be any suffix for them. For sulfonic acid, prefix will be sulfonic and suffix will be sulfonic acid, and sulfonic acids are SO3H. Now see, this all related to all these different functional groups is all over. Now here I'll tell you this is benzene. What this is? Benzene. This is benzene. What about this one? This is toluene. What about this one? If two CH3 groups are there, it will be xylene. If it is on 1 and 2, it is orthoxylene. If it is there on 1 and 3 carbon atoms, then metaxylene. And if these two CH3 groups are there on the first and fourth carbon atom, then it will be known as paraxylene. Now see, this is mesitylene. What this is? Mesitylene. Mesitylene. Now see, what this is? This is phenol. This is phenol. This is phenol. This is phenol. I'll write it here because there is no space. This is phenol. If on first and second carbon atom, two OH are there, then it is catechol. Then it is catechol. This was phenol, catechol. And if it is on first, third, and fifth carbon atom, if it is on first, third, and fifth carbon atom, if it is on first, third, and fifth carbon atom, if it is on first, third, and fifth carbon atom, then it will be known as resorcinol. It will be known as resorcinol. Sorry, not resorcinol, pyrogalol. 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 Now see, this is toluene, as I already told you. This is anisole. Already I explained you. This is aniline. This is already done. So this all is already done. This all is already done. So these all compounds we have already discussed. Benzene substituted compounds. This is nitrobenzene. This is bromobenzene. This is 1,2-dibromobenzene, 1,3-dibromobenzene, 1,4-dibromobenzene. This is ortho. This is meta. When two groups are there, they are on the first and second carbon atom, two continuous carbon atoms, then it is called ortho. Then it is called ortho. But if two groups are there, they are on the first and third carbon atom, that is on alternate position, it is there, one gap is there between them, then it is called meta. Then it is called meta. But if two gaps are there, on first and fourth two groups are there, then it will be known as para. So ortho, meta, para. 1, 2, 1, 3, and 1, 4. This is what ortho, meta, para is. Now see, this all is over. See here, you'll start counting carbons from here, 1, 2, 3, and 4. So on first chloro is there, on second and fourth two nitro are there. So 1 chloro, 2, 4 dinitro, benzene. What about this one? This one is 1, 2, 1, 2, 3, 4. 2 chloro, 1 methyl, 4 nitro, benzene. 2 chloro, 1 methyl, 4 nitro. C comes first now, so chloro. Then M, methyl, and then N, nitro. So alphabetically, 2 chloro, 1 methyl, 4 nitro, benzene. So this will be the IUPAC name of this compound. Now see the next one. See here, 1, 2, 3, 4. On second, chloro is there, and on fourth, methyl is there. So 2 chloro, 4 methyl. And what OMe and benzene ring is anisole. Benzene ring plus OMe, that's OCH3, that is anisole. So on second, chloro is there, on fourth, methyl is there. So 2 chloro, 4 methyl. What rest is anisole. C, 1, 2, 3, 4. This ethyl comes first. So 4 ethyl and then 2 methyl. 4 ethyl, 2 methyl. What rest is aniline. See here on third and fourth, 2 methyl groups are there. So 3, 4 dimethyl. 3, 4 dimethyl. This after this, other than this, what else is there? Phenol. So 3, 4 dimethyl phenol. 3, 4 dimethyl phenol. So now what next is, see here, 1, 2. So 2 ethyl anisole, 2 ethyl anisole or orthoethyl anisole. Now see, 1, 1, 2, 3, 4. On fourth, nitro is there, that is para nitro. What rest is aniline. See here on second and third carbon atom. On second and third carbon atom, this is first, second, third, fourth, fifth. On second and fourth and second and third carbon atoms, 2 bromo are there. So 2, 3 dibromo, 2, 3 dibromo, and on first this phenyl is there. So 2, 3 dibromo, 1 phenyl, and what rest is pentane. Now see here, 1, 2, 3, 3, and this is fourth. On fourth, that is para, ethyl is there. On fourth, ethyl is there, and on second, nitro is there, and one on first, fluoro is there. So 4 ethyl, 1 fluoro, 2 nitro benzene. This will be the IUPAC name of these compounds. So this is all about the IUPAC nomenclature of these, not only IUPAC nomenclature, but common system of nomenclature of all these organic compounds is over. So we should practice all these things from your reference books, and then we'll continue in next class isomerism. And the day after tomorrow, again, morning test will be there. That will be next to the chapter 9, that is S block elements and P block elements, chapter 10 and 11, day after tomorrow, that is Wednesday. So Wednesday हम लोग इन 2 चैप्टर्स से टेस्ट करेंगे जो कि बड़े